this is winter operations. This is session 12. Hopefully we can get to Scott's safety portion of this at the end here. So basically this is just pointing out that, we live in Michigan. Summer can look like this. It can be lovely, nice and green and warm. We can have our towers standing tall, looking good. And then in a few short months, we can go to this. Okay. And basically what this is getting at, just this whole lecture is basically getting at things get cold, things freeze, things break. So trying to keep your mindset on these things. And we talked about a little bit yesterday with water storage and ice issues that come along with that. So some of this, most of this is probably catered towards that. But it's basically trying to figure out how best to maintain your system to limit those freezing issues. Okay, limit those extremely cold conditions. And some of the communities maybe a little bit further south in Michigan might not have to deal with them to the same extent as maybe a UP community. And the same holds true maybe if you're on the west side, maybe you get heavy blizzarding conditions versus downtown Detroit or something like that. That might be a little bit different. Okay. So again, everything's kind of, different, depending on your community, but, things to keep in mind. Plow only where you need to. Okay. Yes, plowing is good. Yes, we often like to have, nice clean area, nice clean driveways and things like this. But remember that snow is an insulator. So don't get carried away like this guy. But it can be good for certain situations that keeps that temperature, those cold winds and things like that, maybe a little bit more protected and things like that. So you're not having, water main breaks, and you're not having, well house issues and things of that nature. Okay. Well houses and pumping station, make sure there's a heating source in there. You can have it well insulated, but you still want some ability to keep some heat in there, especially when you're having extremely low temperatures. Any year something might change and you might have abnormally cold conditions. So it's important to be prepared ahead of time. So install a visual or auto dialer alarm for low temperature warnings. So you're alerted right away when things start getting out of control. Okay. And then again, kind of preparing that fall maintenance, make sure the windows are all together, make sure your insulation is in good shape, make sure you're having, proper weather, gaskets and things on your doors and things like that. And then make sure your hydrants are pumped out, make sure they're not freezing in that fashion. Okay. Storage tank freezing. You may need to sacrifice tank volume by lowering fill level. Okay. So, just in general, your pump cycles, your pump, might change. You might need to have your pump cycling maybe at night to circulate that warm water that we kind of discussed the other day. Make sure you're having that good circulation of water, so you're not just having cold water sitting there for a long time and then just getting colder, especially as the night hits and temperatures drop even more, right? Or a blizzard's coming through. Maybe you got to circulate that a little bit more, so maybe it's greater than 30% of your tank volume. Okay. Again, things to consider as you're going through your yearly preparations and things like that. So recirculation pumps, again, the best and probably cheapest way to make sure that you're not having freezing issues is to rotate that water through. Water is going to be coming out of the ground at that 40-ish degree, maybe 50 degrees or something like that. It's going to be coming out of the ground at a pretty constant temperature all the time. Okay, so it might not be incredibly, warm or something like that, where it's going to be, melting things, but it's going to keep things from freezing, and that's a big thing. So maybe you got to waste some water during that process. Maybe you got to, fluctuate tank heights and things like that. But again, that's important. You can also consider insulating the riser and the tank. We'll give a few examples of that later on. Okay, altitude valves. Got to be careful that those, pilot lines don't freeze, things like that. Make sure your overflows are cleaned out or prepared for that portion. Make sure you're having that solid flap that we discussed. You're not having that chimney effect. Make sure your controls and telemetry are in good shape. that they're not damaged or not working properly. So you can really maintain what's going on in your storage tank. Make sure your vents are working properly, they're cleaned out, make sure there's no debris, so they're not freezing up on you. Make sure your hatches have gaskets and things like that and are sealing properly. Make sure your mud valve is operational and in good shape, so you can waste some water if you need to. And then interior condition, make sure everything's good to go, just in case you ever do need it. Maybe double check those things prior to going into winter, so you're ready to go. Okay, this is, just a, large diameter wet riser, can be an issue, but with large enough diameter, hopefully you're getting enough, water movement out of there. That's really not a big deal. Some systems, and I think we'll get to them in the next, another, large diameter wet riser. So you might not have those issues with that freezing of that riser. Okay. Maybe there's enough turnover of that town that's using enough water, getting that water in and out and getting fresh water in and getting the cold water out and delivering it to your customers. It's important, right? Now, this is an example. We'd seen one similar to this. This was actually a converted one. Went from a wet riser to a dry riser, insulated for that internal portion. Now has a smaller pipe running up to the top. And same here with this one, again, was converted into that. Or actually, no, I'm sorry. This one specifically is dealing with, they were having some issues with short cycling, getting, basically short cycling their tanks. They're trying to get water in there pretty frequently, but essentially that new water never even really got there. So they had freezing problems. So they basically resorted to deep cycling is what we call it. And apparently they have not had problems since. Okay, that's a smaller tank, so it's more prone to freezing and things like that. But they learned their lessons and overcame them. Okay. This is kind of dealing with your telemetry, and there's lots of different options of this. Some people might still have these. Some people might be fully digital now, but these are kind of useful. If need be, you can monitor that tank level, as well as monitoring tank and temperature if you have that ability. So your telemetry is getting back, telling you one thing. And this is an example of what that might look like. This is probably, your standard issue, your normal conditions. Okay, so you're having your tank levels. Where's my cursor at? Here we go. You're having tank levels here. You have your time of day on the outside here. So those are those vertical lines, your horizontal, if you will, or your tank level lines. So looks like maybe this is summer operations or something. What is this, around 15 feet? This looks like it's overnight at around maybe 9-10 o'clock at night. Over the course of the evening, maybe they're not really doing a whole lot, really not much fluctuation until about 6-7 o'clock in the morning, and then they're seeing water usage. So that tank level drops a little bit, down to about 12 feet. They pump back up during the middle of the day, so they're ready for the PM, starting at roughly 3:30, maybe 4 o'clock, and it's dropping down. Okay, and then to about 9-10 o'clock. Okay, pretty standard issue. I would say that probably most people's look something like that, and they're pumping back up and so on, and it's working its way around. But that's normal operation. Maybe that's the middle of summer. Okay, this is kind of abnormal, if you will. This was a situation where they're getting this cycling on and off, pumping on and off. You can actually see these lines here. This is what we call a flow matching. So nothing's really changing here. The flow in is the flow out. Basically, that's a problem. You're not having any tank turnover, and you're gonna actually they did and you will have ice issues. Because you're not getting that turnover. Now you're just basically, freezing out your tank rather than turning it over. All right. So some options that you can do. Apparently this was one of, I'm not sure actually. Let's see here. What do the speaker notes say? Trout Creek about 1989, apparently. This slide was taken actually in 2006. So this is one of the oldest spray foam insulation tanks, apparently in the state. This is about an inch thick of spray foam. As you can see, there's probably some rust here. So whether that's failing or whatever is exactly going on here, there's some issues. So it might need to be rehabbed to some extent. But they put this insulation in, and they basically haven't had those same issues of freezing. Okay, and this is another example. Again, this is a smoother maybe version of that. They put some foam insulation on the the exterior of that to keep that insulated tank. This tank has a double riser. Obviously, you can't tell that from a distance, but again, it's that pumping out the top and then draining out the bottom. So you're doing okay. You're having that decent turnover in water. So you're never having just that stagnant water sitting there and freezing over. They really have not had many issues. Okay. Let's see here. Oh, this one was converted as well. So a wet riser, originally large diameter wet riser, ended up changing it. As you can see, they kind of, did their own little, reconstruction there to have that in an insulated portion there. Yeah, so it's just an example of what can be done. Now, what comes along with, an unfenced tank, there's no fence around this one. This is foam. You can have some vandalism. Looks like that might have been shot with a shotgun at some point in time, whether it's a disgruntled employee or something, I'm not certain. But that's something to keep in mind. So they kind of took that option away to not damage the insulation. And then, so you're getting the actual aluminum curtain there. And then this is a standpipe. Again, kind of that exterior coating around a 1-inch fiberglass insulation. You can't necessarily tell that, but pretty straightforward. This is what it looked like originally. Now it has fence around it to actually, did that have, oh, this also had fence. But yes, so that, preventing that potential for vandalism and ruining your tank and things like this. We talked about this one yesterday. So yeah, built an exterior building around an old tank. And it obviously helps with that heating portion of that, because of that little bit of insulation that we can see here. What is that, a couple of feet or whatever worth of insulation? Now they're not having those same issues with freezing that you would in a large standpipe like that. Okay. Here again, another example we discussed yesterday. You have your elevated storage tank, but you also have your ground storage as well. So that lower tank might have some issues, but with enough turnover, you're not going to have. Did I say large tank? I meant that small tank, the elevated storage tank, might have some freezing issues, but they work with it enough and have enough turnover where they're not having that. Where that ground storage tank isn't probably going through the same issues because it's insulated by the ground and the hill that's there. Okay. Again, discuss this, making sure that you don't have just a direct screen because it can create that chimney effect, which is basically, having that heavy draft of air, pumping that, off the top of the tank, and then you're going to basically be creating that floating layer of ice on top that we typically refer to as an ice cake, okay, which can cause issues, can cause tank failure at the end of the year. Maybe that, you build some up on the top. So as it warms up, that ice might fall and damage the bottom of the tank, things like that. Okay. Again, that trickling effect. So we want to, make sure that there's that ability to drip some water out throughout the course of the winter. Even if that does, potentially freeze over a little bit, but whether that's drilling a hole or putting a little bead at the end of the, to keep that away from the siding. Okay. This is an example of, even with that, or actually it looks like they might have left that flap open. And that's a good example of that. You're going to be, freezing that overflow a little bit. Okay. This is just kind of pointing out, severe, icing could cause, freezing of the pallet. That's just for the vent that we discussed. I think I discussed this enough yesterday, but making sure that you have frost-free vents or that they're properly maintained throughout the rest of the year, so you're not having those issues. Okay. Vents are important, as we discussed, because you can have, situations, both vacuum situations as well as high pressurized situations. Unfortunately, this was a sad instance. This specific one, actually ended up taking a man's life at one point in time, an operator's life, as this was actually sealed over, was frozen over. And so they took the locks off. We're trying to open it up, try to kind of, bust that hatch open. So they kind of kicked it. It popped open, ended up knocking the operator out. He ended up falling into the tank and dying in there. Okay, so this is, just another reminder that maintaining safety and things like that as you're going about your everyday job. These things are not to be, we're dealing with large scale issues. So make sure you're being as smart as possible in all situations, making sure your equipment is working the way it should be. And if it's not, using those precautions as best as possible to minimize hazards and things like that. Okay. So this is, just a, standard issue elevated storage tank. They were having chronic freezing problems during the winter. So they went through and did their foam insulation, I should say. Now the kind of the point of this is, though, you might be upset because you don't want to get rid of your, community identity that we talked about, but obviously there's always ways around that. You can still paint it. You can still do certain things. You can make it look nice and keep that portion of it. Now, with that being said, that doesn't always mean that people might like it, or there still might be some vandalism. As you can tell, some upset individual or whatever the circumstance may be felt the need to launch an arrow at the poor smiley face. Okay. Again, if you have concrete tanks, whether it's, buried underground or partially buried, things like that, maybe you're not having those same issues. It's banked in with the earth, so you're having that insulation keeps from freezing, right? This is an example that we showed yesterday. They got venting. Maybe they have some issues with the roofing there, but now they, put some new roofing on. Maybe some additional layer of insulation there, keeps that clean, keeps that a little bit warmer, so you're not having those freezing issues. Similar thing here. This tank was actually built in the 1880s. So this, is over 100 years old. It's still technically in good shape, at least in terms of structurally. As you can see here, maybe there's some pitting in the roofs. Maybe it's starting to come apart a little bit. Maybe you have an older style of vent and hatch here, but they at one point in time rehabbed it. I'm not sure exactly when that occurred, but they got a new vent, new layer, so it looks nice. So it's going to be protective to that coating, so structurally it'll be sound. You got a new, hatch there in neat. Okay. Again, they got some supports here. It's a ground tank. It's going to be fairly insulated. They're not going to have many issues. We discussed mixers yesterday as well. Mixers can be important for lots of things, whether it's limiting DBPs and things like that, but it can also, to some extent, help with that, moving that water around so you're not having the same kind of freezing issues. There's a little bit of freezing prevention that comes along with it. Okay. So thawing mains, there's lots of different methods, whether it's a steam jetting or welders. I really shouldn't even probably be mentioning welders because I'm actually going to skip that portion because we shouldn't even be using them, and I'll hit on that. You can use jet machines. You can use propane coal-fired heaters, things like that. Need to maintain steady flow through the mains to prevent refreezing. Okay, and then your last option, right? Wait for spring, right? Wait for that warmth to come back because there's only so many things you can do at the end of the day. Again, here's the thawing of an actual service line. So thawing machines, whatever that might be. Again, probably shouldn't mention welders, but people do use them. Steam Jenny, again, maintaining that flow. Sometimes you have those let runs or whatever during the winter in certain communities, and then wait for spring again. Hydrants, same kind of things. Maybe you have preventing from freezing by plugging the weep holes, obviously, pumping that hydrant down, and maybe even potentially adding a food grade antifreeze like a propylene glycol or something like that to kind of prevent from that. Okay, storage tank. There's really not a whole lot to be done, unfortunately, just because of the size. You can try, anything you want. That doesn't mean it's necessarily going to work. There's lots of instances of trying to use, steam jennies and things like that. You might be able to break up a little bit, but in the long run, with that much ice, it's very difficult. People have tried to use augers and things like that. You can drain and isolate and do all these things, but at the end of the day, it's very difficult to overcome. So essentially what you're talking about is wait for spring and return to summer operating levels. As I discussed a few moments ago, return to those summer operating levels maybe a little early. So when that warmth does kick in, you're not having falling ice off the walls that might damage the bottom of the tank or whatever equipment that you have in there, whether it's the hatches or the mixers or something like that. You might have some issues. Okay. This is an example of a steam jenny working on a hydrant there. Essentially, you have that actual heating portion there. This is kind of just their own operating rig there that they can hang on to, so it's not coming in direct contact with the hot source, and then it's pumping that steam down into that hydrant. Okay. Again, welders. The use of welders, electric welders is prohibited. Basically, what you need to learn from this is that they can be extreme fire hazards. When you're playing with electricity and you're just connecting it to metallic piping, you can have issues. You can have shorting, you can have circuiting, issues like that, and realize that you could burn a house down very quickly doing this. So I'm actually not going to hit on a lot of this welder portion of this. Obviously, there's liability issues and things like that. Again, not really hitting on this. This is kind of just driving that point home. Lack of continuity. There's a lot of things that can go wrong, whether it's different in pipe material and things like that, repair clamps, flares, compression fittings, and other utilities and things like that. Copper banding to kind of help with that. But again, we do not recommend it. We recommend against doing this. Again, kind of just driving this point home, compression fittings, steps for thawing services electrically. Again, I'm not going to hit on this because I don't believe we should be teaching this because it's, again, prohibited. Again, kind of getting into this, as one once said, electrical thawing of service lines is like playing with lightning. Well, it quite literally is, to some extent. And you can have these issues, but this is an example of people still doing it. It does work. I'm not going to say it doesn't to some extent, but you can have issues. There's improper ways of doing things. There's proper ways of doing things, but I would recommend just not even getting down that route. Okay. So this is just kind of an example. You might have this welder set up working on this house and this house, as you can see by these lines here, and yet you can still have a fire. And this was an actual, example. I forget which community this was, but it was up in the UP. This actually occurred, not even that long ago, less than 15 or 20 years. Okay. Here's some equipment that would do that. So pulse jet, or I'm sorry, here's additional equipment that might be able to, help with those service line materials. So, different pulse jet deicers, things like that, that can help, alleviate that icing conditions and things like that, recycling the water, allowing that heat to come, fresh water heat to come through, and doing it that way. Okay. So there are other alternatives to using that electrical, option. Okay. Yep. Same sort of thing. You got trouble spots still. If you got 90-degree bends, old valves, things like that. If you have, galvanized lines, whether that's, heavy tuberculation, things like that, and you're not able to run that through. And then this is just kind of, examples of how to use it, how to properly operate it. Pulse or flow mode, fill water level 3/4 full, warm water 95 to 105 degrees. You have an on-off switch, obviously. Unwind the tubing, disconnect the service, connect machine, open the valve on the probe end or probe head, and then basically you're going to be feeding that pulsing of water and trying to warm up that service line again. Okay. Water mains. In severe climates, maybe you're putting a styrofoam sheet over the top of it to help insulate. Maybe you're putting at deeper depths than you normally would in some situations. But again, just trying different methods if you're having this continued chronic issue of freezing. Water mains and sewers, you can have severe climates, permafrost, things like that. So maybe you're having insulated lines in utility tunnels and things like that. Okay. Again, permafrost, insulated lines, whether that's above grade, especially continuous circulation pumps, depending on wherever they're needed, and then auxiliary heating when needed. Okay. Situations like this, if you have a bridge and you have water main coming across rather than being buried underground, it's just running alongside that bridge. Obviously, that's completely exposed. So making sure that they're insulated on rigid joints, joint hangers and things like that. And then having a valve and manhole on each end. Big issue is salt as well. So during those winter months, you can have excessive corrosion issues on the exterior portion of that pipe. Okay. So again, just things to keep in the back of your mind as you're going through, your everyday. Maybe you won't have to deal with most of these things, hopefully not, but some communities might. So it's kind of getting everybody on the same, wavelength and thinking in the right direction so they can handle their own situations the way they need to be handled.